Hello everyone, this is Hassan from Mouthful Economics. In this video, we'll talk about transpose of a matrix and adjoint matrix. Transpose of a matrix and adjoint matrix. Now first we'll talk about transpose of a matrix. Say for example we have a matrix A which is our 2 by 2 matrix with elements A11, A12, A21 and A22. Now if we want to find out transpose of matrix A, say AT, what we have to do, we have to just convert these columns into rows. So the first column A11, A21 becomes the first row A11, A21, and the second column A1222 becomes the second row A12, A22. So for example, we have a matrix D which is equal to 2, 3, 4, 5. This is a 2 by 2 matrix, square matrix. So D transpose will be equal to first column will be turned into first row 2, 4, and second column will be turned into second row 3, 5. You can also find out transpose for any non-square matrix. Say F is a matrix 1, 2, 3. Here there are 3 rows but 1 column. Now transpose of this matrix FT will actually be 1 by 3 matrix. So here we'll have 1, 2 and 3. Again we have a matrix G which is equal to 1, 2, 3, 4, 5, 6. 3 by 2 matrix. If we want to find out GT, transpose of this matrix will be the first column will be turned into first row 1, 3, 5, and the second column here will be turned into second row which is 2, 4, 6. So this is a 2 by 3 matrix. This means there are 2 rows and 3 columns. Now say for example we have a matrix B which is equal to 2, 1, 1, minus 1, minus 2, 1 and minus 1, 2, 1. Now transpose of this matrix BT will be equal to first column will be turned into first row, so this is 2, 1, 1. Second column will be turned into second row, so minus 1, minus 2 and 1. Third column turned into third row, so this will be minus 1, 2, 1. Now in one of our previous videos we found out the cofactor matrix for this matrix B, which was CB is equal to minus 4, 2, 0, 1, 1, minus 3 and 3, minus 3, minus 3. If you have forgotten the rule, just go and revise the video with minors and cofactors. Now if you transpose this matrix, say CB IT, we will have column will be turned into first row -4 to 0. The second column will be turned into second row 1 1 -3, and the third column will be turned into third row 3 -3 -3. Now this matrix has a special name which is known as Adjoint Matrix. Now again, say you have an identity matrix I, which is equal to 1 0 0 0 1 0 0 0 1. If you want to find out transpose of this matrix IT, then the first column will be turned into first row 1 0 0. The second column will be turned into second row 0 1 0, and the third column will be turned into third row 0 0 1. Therefore, we see that these two matrices are exactly same. So we can say for any identity matrix I will be equal to its own transpose. This is all for now. Don't forget to practice. There is one disclaimer though, not a native English speaker, therefore following my grammar and pronunciation is subject to tremendous risk. Anyway, if you are new to this channel, don't forget to like, share and subscribe. Want to learn more? Follow the link in the description below. Bye bye.